So we have an example problem here. We're asked to calculate the values of E1, EMF1, so battery 1, which is labeled here on the left, and EMF3, the battery in the middle. In this case, notice they've given us and shown us an arrow right here telling us this current. That current will flow from junction to junction in this left-hand branch. They've also given us a current right here that they're calling I2. That represents the current flowing out of this EMF2, but it would also represent the current flowing in to EMF2. If they give us a direction of the current, we have to use it. Now, the current through the middle, we've got to get right here, but I hope it's not hard to see. If I have I1, and sorry, I labeled that one on the right, they have it I2. So with the way they've drawn the picture for us, we have I1 traveling towards that top junction. We also have I2 traveling towards that top junction. Therefore, I3 must flow down just to satisfy the flow of charge. We can't have all the currents flowing to that junction because there's not a hole or something there to collect all the charges. Now, because we have a battery in each branch, we have to use Kirchhoff's equations. So, Kirchhoff's rules or laws. So we have the junction law, which, if I look at just this top junction here, the problem itself showed me that I1 was traveling towards that junction, as was I2. So I can say that I1 plus I2 has to equal I3. Now, the other thing I'm going to go ahead and do is throw in these numbers they told me. It looks like we're missing our amps on that I2. But we have 4 amps plus 4 amps, so we actually know I3 is 8 amps. It wasn't labeled, but because of the currents they did give us, we can easily come up with that I3. Now, ultimately, what we want to find are these two battery voltages. The voltage, of course, does not show up in the junction rule. It will show up in the loop rules. But the junction rule is necessary to determine this current of 8 amps because that will determine the delta V for this 5 ohm resistor in the middle. So delta V's. The delta V for a resistor is I times R. So delta V for this 5 ohm resistor is going to be 8 amps times 5 ohms. And I believe that's 40, but I'm going to double check myself. 40 volts. So we know the value of delta V here. Similarly, the 4 ohm resistor up here, I1 is the current flowing through it. I1 is 4 amps. So 4 amps times 4 ohms tells me there's 16 volts across that top 4 ohm resistor. This down here, the bottom 4 ohm resistor. The current flowing through it is I1, which is also 4 amps. Its resistance is 4 ohms, so this is also 16 volts. The other resistor we have is this 6 ohm resistor. The current flowing through it is I2. I2 was given to us as 4 amps. The resistance is 6 ohms, so there's 24 volts across this one. And then, of course, there's 20 volts is that EMF 2, and we're looking for EMF 1 and EMF 3. All right, so loop rules. We're adding potential differences. Let me write that better. Adding up potential differences across all elements in the loop. They must add up to be 0. Okay. Now, I know I have 2 unknown batteries here. What I'd like to do first is look at a loop that includes only one of the batteries. So, meaning I either want to look at the right-hand loop or the whole outside perimeter. Or both, because they would include different batteries. So, let's just go ahead and do the outside loop first. Now remember, loop rule, we just need to end where we start. So just let's choose a place to start. I'm choosing the bottom right-hand corner. And I want to go around the whole outside loop. Whether I go towards this 20-volt battery first or go left towards the EMF 1 first, doesn't matter. What matters is that I end up where I started. Okay, let's go ahead and go upwards. So going up, I'm going to see the potential difference across this 6 ohm resistor. Since I'm going with current and current flows high to low, my path takes me to the low end. I'm going to see a drop of the voltage delta V for this 6 ohm resistor, which I know is 24. I'm going to plug that in a minute. I'm going to set this up symbolically first. As I continue my path, the next thing I'm passing by is this 20 volt battery. My path is taking me upwards. That means I'm going low to high, so I'm going to see an increase of this EMF 2, which I'm going to put the values in a minute. I keep going, my path, I have to turn up here. The next element I am passing by is this top 4 ohm resistor. I'm going opposite the current. So current flows high to low. So if my path is taking me to the left, I'm going to see an increase of a delta V4, meaning the 4 ohm resistor, which I know the value. We're going to plug that in. Okay, I keep coming. Let me erase a little bit of my colors over here. Around my path, the next actual element I pass is this battery. My path is taking me towards the low end of that battery, so I'm going to see a decrease, a drop in that EMF 1. But again, I got to get back to where I started. So my path, I need to keep coming down. I'm going to turn. I'm now going through this 4 ohm resistor on the bottom. Because current flows high to low, and my path is going to the right towards this positive end, I'm going to see an increase of the delta V through that 4 ohm resistor, which we know. That's going to get us back here to where we started. So we're now ending at the same location we started at, which means we now need to make this a full-on equation and say it equals 0. Okay, I'm going to go ahead and put the voltage values I know in. So delta V6 was 24 volts. EMF2 is 20 volts. Delta V4 is 16 volts. I do not know EMF1. And then the other delta V for 4 ohm resistor is 16 volts as well. This one ended up a lot less involved in terms of algebra because we knew all these voltages. Well, you had to calculate them from I times R, but because we were given current values, these were essentially easier to calculate than the previous example where we had a bunch more algebra to do. So 32, 28. 28 volts is battery 1. So this voltage over here is 28 volts now. It needs to be 28 volts to have that 4 amps of current flowing out. The other unknown we want to find is the battery 3, the EMF 3. To calculate that, we want to either complete the left loop or the right loop. Whichever loop we take is going to be fine. We just want to make sure our path takes us down this middle branch that has EMF 3 in it. Let's go ahead and just do the right loop. We can start where we started last time. So, meaning as we go up, we're still going to see that drop of delta V6. The delta V for that 6 ohm resistor. We see the drop because we're going with the current. As we continue, we're going to see an increase of that battery voltage, the 20 volts. We keep going. This time we have to go down through this resistor. We're going with the current again. With the current always means we're going to see a drop. I'm going to call that delta V5 for this 5 ohm resistor. As we continue, we're going to pass by this third battery. Since the path we're taking has us seeing the positive end of the battery last, we're going to add that EMF. This gets us back and ends where we started. So to end our equation and make it a full equation, we have to say equals 0. So let's go ahead and put the values in. We already found that delta V6 is 24. EMF2 is 20 volts. Delta V for the 5 ohm resistor is 40 volts. EMF3 is what we're looking for, which happens to be, let me write it the other way. So if we take all the numbers to the other side, we get 44 volts. So this is telling us that a battery of 44 volts in the middle, a battery of 28 volts on the left, and the 20 volts that we were given in the first place will result in these currents of the 4 amps that were given in the problem to begin with. So it's all about writing out our junction equation and a couple of loop equations. Typically, if we've been given a current, it simplifies the algebra a little bit. Doesn't mean it makes it easy. It just simplifies the algebra a little bit. Okay, please reach out and ask questions as you're practicing these. It's the signs that matter, adding and subtracting voltages, getting our equations set up to then solve.